Well, today's a fun day. We are going to be piloting some new material. So last fall, some CSUMB students were wondering if they could help out in some way. They have a service learning requirement. And I said, sure, you could try to rework some of the labs that I really, and presentations that I really don't like it that much anymore, and this is one of them. So this is a review of arrays that we're going to cover today. We've already been working with arrays, so you might feel pretty comfortable, but arrays can be much more involving than what we've used so far. So, and we're going to need to practice working with arrays so that we can develop the data structures that use arrays more efficiently and more effectively. So that's what the purpose of today's lab is. Hi, Ben. And the way this used to work is I used to do this really long, tedious thing where I would demonstrate stuff and people would type what I typed and I would explain as we went. And since I was running out of time, I was going to just bail and just do that again, but I'm trying to get out to a meeting. I'm going to be leaving around 3:45 to visit a curriculum meeting. I'm trying to get some revisions in on my engineering program. So I will just start you off and then have Ben just kind of help you for the rest of the time that I'm away. It might not be too long, but that was my incentive to get this thing reorganized. So we're doing Lab 2B 3A still, and what was formerly under construction is now live. And the things we're going to look at are arrays and linked nodes. It's just arrays right now. Linked nodes will come for Monday. And that should come up okay in your window. And this was, yeah, so this was developed by Bianca Hernandez from, do you know Bianca? Ben? CSUMB? Chanel, Nicole Aquino. And who else was there? Peter, yeah, I shared it with him. I don't think he did it. I don't know, maybe he did. Yeah, it's mainly Chanel and Bianca that did this. And Christine. Anyway, they put this together. It was really nice for them to do this. They cleaned up the slides. Seem to go away. And then here is the lab we're going to be doing. And I'm going to pass this out. Maybe I'll just pass this out right now.
Oh, there's one. I get an extra.
Extras?
We need one more.
What else do you want? I'll leave the rest right here right now. So it's very concise, not a whole lot of explanation. So there's going to be some hints in the lecture slides on how to tackle these. But you can see what's going on here. We've got 6 arrays, and kind of like a coding bed activity, you're going to be processing them with some methods. You're going to write a bunch of methods to process them. So you're going to find the sum of all the elements in an array. You probably know how to do that already. We already did that, right? We did that in the average cost thing, right? So you kind of did that already. But searching for a value, you're gonna be doing that, returning true or false if it's in the array. Finding the minimum, finding the maximum, removing an element from an array. This is actually interesting. The array initially had 5 items. After you remove it, it's only going to have 4. So how do you do that? We're going to talk about that. Inserting an element at the beginning. So there was 4 when you insert an item at the beginning. Now there's 5. Okay, you're going to have to figure out how to do that. Replacing an item at the end, that's not too hard. Replacing an item at some position is not that hard either, unless you want to put some security on there to make sure people can't insert. I might do that next time. I haven't. Well, you know what's fun about doing this in Google Docs is I can add. Ooh, this should be good. All right, so what if I add another one here, which is, did you say no? Put a, this is what I was just sort of thinking would be nice. I literally was working on this all morning and into the afternoon. So if you put a 15 at position, or you try to replace a position 8, you should not get an exception thrown. Okay, that's a good one, right? Because if you try to access cell 8 in an array that only has 5 locations, you'll get a index out of bounds error. So do that without an error, right? No change, no error. So that gives you a little bit of a challenge, right, to come up with the logic of that so that you don't do anything illegal. You could try shifting an array by some value. So in other words, shifting everything. If you had array 1 like this, shifting it by 1 means the 5 comes to the beginning and everything slides over to the right one. You could do it by 2. You can give it by some value, or -2, shifting it the other direction. Combining the following arrays in alternating order. This is actually kind of interesting. Combining array 1 and array 6. But look at what array 6 is. Array 6 is what? An array of what? Char. How are you going to combine an array of char with an array of integers? Turn them both into strings? Well, but look at what you're supposed to get. It's actually integer. They're all numbers. So what could you do instead of turning them both into strings? What's the, you see how they're interleaving, right? So it's basically taking one from one from the other. What's the 65 mean? What's 66? So the 24 is the first number in, well, it used to be until it got shifted. It's first number in array 1, right? So what's the 65 doing there? Yeah, that's the ASCII code for A, the letter A. So if you take a char value and cast it as an integer, you can do that. You're going to turn an A in single quotes into a number 65. So that's extra credit, and this test plan might not be perfect compared to what's going to happen before that. These tests are cumulative, so when you change the array in this step, it's reflected in what you're going to see in this step. So you're going to keep all of the code active as you build on more and more of the answers. And so that's the lab. And then here is the lecture, which is right. Well, it's under there. Let me pull it up. It's right there. And by lecture, I mean that this could be your resource. I'm going to flip through them relatively quickly and kind of give you a rundown on what's there. Oh, you know what I was going to do is maybe if there's time, add some pictures. So let me download this as a PowerPoint slide. You won't be able to get the markups, but You might not want to have a piece. You might want to have a piece of paper out, so when I do sketch some things, you can actually sketch them as well. So by now, I think everybody has a pretty good grasp of arrays. So I don't think I need to spend too much time on this. You know that all the items in an array have the same type, and you can declare arrays and instantiate them using a syntax like this, or you can combine and do them all at once. You can also you can create the array with the default values. In this case, these are all going to be zeros, or you can declare them with what's called an initialization list. And that's how the arrays in the lab are created. Arrays of reference type, like string, for instance, are not initialized. They actually have null values in the cells, and so you have to initialize them with your own values. So again, these are some examples of ways to instantiate an array. And you want to, the recommendation is to instantiate them as soon as you declare them, rather than declaring them first and instantiating them later. You can access an array element at some location in the array. What does this print? What comes out when this runs? The letter B. Because arrays start at location 0, right? And if you could put like a bunch of numbers above these. And grades of 2 equals E, what is the effect of this statement? Yeah, the C is going to be replaced by the letter E, right? So you can make a loop to access all the elements in an array. This is an array that has 100 items, and we make a for loop that goes from 0 to 99 and prints out whatever value of I is that location in the array. So that's one way to print the items in an array. What's the index of the first element of the array with size n? 0. And the word index refers to the location, right? So this is what we call the index. And the index of the last element in an array of size n is n minus 1. If you do try to refer to element n, you'll get an array out of bounds error. And which one of those is the proper way to determine the length of an array? A, B, C, or D? B, it's B. ARR.length. It's and what if it's a string? Which is the way to find the size of a string? Sorry. It's A, right? Yeah, sizes of a string are like this, because for string, this is a method. For arrays, it's an instance variable. What does this code do? Well, it's using the length variable of an array, the length field of an array, to indicate how far the loop should go. So instead of actually using 100 here, it's better to use length, because that's going to adjust itself if you change the size of the array later, right? It'll always be reflecting the current length of the array, which is really helpful. It is also advisable to, when you declare arrays, to make them with a constant, the size, so that if you do change the size, you just have to change it in one place. And then everywhere else that you're declaring arrays, you're going to use that constant there. And this is how you declare a constant. You put the word final in front of a regular declaration, and we typically use uppercase for the letters of a constant, meaning it's never going to change. It's like hard-coded, it's fixed while the program runs. And the word final prevents you from changing this to something else in the code. Yeah, I mean, you give it a size of 1,000, and you can, if that's, that's going to be the size of your array in the program. So you can't later on change array size to 90 and redo a new, You'd have to you can change this and recompile it, but while the program runs, the array size is fixed. Yeah. The idea of this is a little mysterious, I think, probably when you see it. But the idea is, suppose you needed to make like a bunch of arrays that all had the same size. Make one constant variable that has the size, so that if you need to change that, you just change it right there in your code and recompile it, and then they're all aligned properly. Yeah, it's yeah. That was something that they wanted to impress on you. These are all people taking coding classes at CSUMB, and so they're talking about the things that are coding practices that they recommend. We don't actually have any two-dimensional array problems. I'd like to maybe add one of those next year. But right now, if you do need to ever access a 2D array, and they can be useful, and you might decide to use them on your project, a two-dimensional array is an array of arrays. And if it's a 3D array, you have 3 square brackets. For 2D array, you have 2 square brackets. So this is going to make a two-dimensional array. And you refer to them kind of like in a coordinate system. You do the row first and then the column. So to access the third element of the second row would be this guy right here. You would say A of 1, 2, right? So this shows some two-dimensional arrays being created. There's double square brackets there. And then it's a 5 by 12 array, 5 rows and 12 columns. We're not seeing that one. And then this is a 3D array, which has 4 rows, 3 columns, and like 2 sheets. So you can have sheets sort of stacking up on top of each other. You can also initialize arrays with 2D arrays with an initialization list. You can see that it's nested. So this one, the outer curly braces are controlling the number of rows, and then this is what's the content of each row, right? Inside a set of curly braces themselves, each row is set aside like that. So that sets up a two-dimensional array. It can be kind of fun to play with. And that is your review of arrays. Like I said, you can refer to this if you want to get some coding advice on basic syntax of how to do things. The next section is just some stuff I threw together on the steps you're going to need to use to solve the problems on the handout. So the problems on the handout, if you came in late, there's a handout to the right of Ben there near the chair. And you can pick that up as a guide for what you're going to do in the array, in the lab. So you all know, I think, at this point, how to calculate the sum of the items in an array. And so that would be adding up all these values together. You make a sum or a total variable, set it equal to 0, and use a for loop to visit each item in the array and add it to the sum. So you say something like sum equals sum plus scores of k. What if you want to know if a particular item is in the array? Suppose you want to look and see if the number 73 is in the array. What if you're trying to find if that's in the array? Well, what you're going to have to do is you're going to have to visit each item in the array in a loop, right? So this is a loop. And if the item matches the target item, like if you're trying to look for a 73, you would have to give the item that you're looking for to the method. And if you do find a match, you return true. But if you've gone through the whole loop and you haven't returned true, what does that mean? It's not there, so then you just return false after the loop is over. Okay, so that's going to be number 2. Finding the minimum value in an array is pretty straightforward. You define a min variable and assign it to the first item in the array. So in this case, you would put scores of 0 into min, right? So the first item, you just assume that's the minimum. And then you visit the remaining items, and if you find one of the array items is smaller than min, you replace min with that particular array item, right? So you say min equals scores of k. If scores of k is less than min equals scores of k. So that's how you find the min. When you go through that whole array, at the end, you're going to have the smallest item in the min variable, and then just return that. There are some thoughts on copying an array into a new array, and I'm kind of showing some basic principles here, but if you have a scores array and you make scores copy a new integer of size scores.length, that ensures that your copy array has the same size as the source array. You can then copy over the items one at a time into the new array, so now they both have the same data. But doing it this way is not very flexible. If the size of the array changes, you have to add additional lines of code there, right? So what we do is we use a for loop, and we can just do something like this, and then scores copy of index equals scores of index adjusted to the size of the array, much better. Now, number 5, you're asked to remove an item from an array, and that's sort of an interesting problem. Suppose we want to remove the 56 from the array. You have to make a new array that's going to be one smaller than the size of the scores array, because it's going to end up with one less item in it, right? So this should be kind of fun to solve. If you want to remove the 56, you're going to have to make scores copy equal a new int with scores.length minus 1 as size. See that? So that you have one less item in the array. But then you got to figure out how to copy over the items into the new array. So here's the new array. It's going to have one space left. One of them is going to be missing in scores copy. Here's my sketching. I would like to have had this done before the lecture, but I didn't have time. So you have to copy every item that's not the one that you're trying to remove into the array, but then you skip over the one that you're trying to remove, and then these you have to move over a location. Okay, so this has to go here, this has to go here, this has to go here, like that, right? How do you know it's going to be 56 or 73? Well, your method, the method that you write, because all these problems that you're going to solve by writing a method. And we'll do the first one together so you kind of see how that works. But the method is going to receive the item that you're trying to remove from the array. And so, that's going to be another parameter for the array, for the method. Yeah, in fact, just to kind of clarify that, because it is a little bit of scattered, if you look again at the lab, so the method that you write has to receive the item that you're trying to remove as well as the array, right? So these are the two arguments to the call to the method that's going to do the remove operation. No, it's going to just be remove parentheses ARR1, 12. Yeah, so the remove is a static method you're going to write below, but we'll show you how that works. Yeah. Yeah, I was just thinking about that. See, I had to make this so fast, I couldn't think of all these things. If an element in these arrays all have unique elements, I think, so it's not going to happen in this case, but you can think about that. I think for sanity's sake, you should just remove the first occurrence of that item, because that way you know that you're only going to reduce the size by 1, right? If you have to count how many there are first and then do the size, it's more complicated. Certainly for an additional challenge, you can think about how to do that. But just to keep it sane, let's just say there's only going to be one thing. So the purpose of having 3 different arrays for each of these test cases means you can't hard code your answer for one particular array. You actually have to make your code general so that it works with any array that you give it and any value that you're trying to remove. So you have to set it up that way as an algorithm. This is why this is called array algorithms. So this might be it's a little more challenging than what I would have done before, what I did last year, but I think you'll find it pretty interesting. Now, why did it all, I'm in here. So that's removing, to continue, you do that copy all. This is the step I just sort of described up here. And that shifting has to take place. And then you would assign to scores the scores copy array to complete the change. So scores equals scores copy. Now scores is referring to the new array. So scores has now been, it has an array that's one smaller than it originally started off. That makes sense? If I'm going too fast, Ben here will explain it all in great detail after I leave. The other thing, so that's removing, this should say 6, I think. Inserting an item into an array is going the other way. Suppose you want to insert a 25 at the start, and the insert operation is always just going to be at the beginning of it. You're just going to add a new item to the front of the array. So if you want to add a new item to the front, you have to make a new array that's 1 larger than the size of the scores array. So you're going to say scores.length plus 1. And copy the new item to be inserted into the first location of the copy. So now, right, you've got an extra location here. I probably should do it more like it's going to be lined up, because we start both arrays at 0, but the scores copy now has an extra one. And the first item is going to be the item that you're trying to insert. And then you have to kind of move, you have to put the rest of the items in the scores array in a location that's 1 over from where they were in the scores array. So you have to do that with a little bit of an offset, okay? And so that's where it says you have to shift these over 1 location. And then again, when you're finished, assign to scores the scores copy array. In other words, scores equals scores copy. So now the scores array is referring to the new array that has 1 extra item inside. Some extra goodies you might not need, probably don't need. I wanted to point out that there's a really nifty way, if you're just copying an array, which we don't really need to use in this lab. There's an interesting class called java.util.arrays, which has a bunch of static methods for processing arrays. Ben is rubbing his hands. He likes them a lot. Yeah, so rather than making a for loop to copy this item to this item, you can invoke, so you could say scores copy equals arrays.copy of scores to scores.length. I mean, this is the array, and this is how many. So you could copy the entire scores array into a copy, and this would just do it without any for loops. It just does all that for you behind the scenes. I was hoping that you could use this in these problems, but you don't want the scores copy to be an identical copy because you have to move things around a lot. So making a carbon copy of the original array isn't going to help you in this case. But there may be other situations where it could be helpful, just not in this lab. However, one thing we are going to use is the toString method for the arrays. Are you guys getting all this? I'm kind of talking fast. But like I said, Ben will be here, so he can kind of rewind this if necessary. Like, instead of printing out all the items in an array, which is sort of done way up here at the beginning, this one right here is printing out all the items in an array. Can't erase that right now, right? A for loop, which is painful, right? If you don't have to do that, why do that? You can print out all the items in an array with the arrays.toString method. And it's a weird thing. Normally, the toString method doesn't take an argument, but this arrays.toString method takes the array that you want to print out, and it turns all the contents of that array into a string. So it looks like this. Arrays.toString of scores copy will turn scores copy into a string, and we're just adding that to this string, so it actually prints it out all on one line. You could even trim, if you need to, like if you do something like this, scores copy scores.length -1, you would get an array that has up to the last item, but not including. So you would get one that's a little bit shorter, Or you can make an array that's a little bit larger. I hope this doesn't distract you. I just want to throw that in. We're going to see that later, so there's no reason. I should probably just do that. One thing I do want to talk about, though, is that I want to emphasize the importance of being able to look at a loop and being able to predict what it's actually going to do. And as an example of that, I have this code here. So this is a for loop that goes up to the length of the scores array, and then it has an if statement inside, and depending on the value of k, it's either going to assign scores of k equal to scores of k plus 1, and think about what that's actually going to do, or it's going to just let scores of k equal the value of k minus 1. Now, you might think you have a pretty good understanding of what this code is going to do, but if you don't, you might be wondering, how would I understand it? And what I want to emphasize is a couple things when you're working with arrays that can kind of help you when you're devising your own algorithms to processing arrays, or trying to debug your code that's processing an array that doesn't work. Is that you can always trace, or sometimes I like to call it unwrap, a for loop. By unwrapping, what I mean is you can basically just plug in to the body of the for loop all the different values of k that for loop is going to be processing with real numbers, and then it'll make a lot more sense. So for instance, here's the code. If you unwrap this for loop, you can put the number 0 initially is the value of k, and you can basically interpret all this thing as actual real indices, right? So it's actually a lot more readable when you see numbers in those square brackets than when you see symbols like k or k plus 1. So, and there will be, I think, some little problems like this on the drill assessments for this week, or for lab 3. So, you know, if k is 0, what that means is if 0 is less than 5, scores of 0 equals scores of 0 plus 1. So what happens when I set scores of 0 equals scores of 1? What does that actually do? The item at position 1 is copied into position 0 of the array, right? That's the kind of offset that you're going to have to do when you do like a remove or a insert. You have to move things over by one location, and you can do that with a kind of a k in one square bracket and a k plus 1 or a k minus 1 in the other square bracket. So looking at it this way, you know, you've unwrapped the first iteration. The next iteration is just putting a 1 where k is. You can see that nothing mysterious. The k is now replaced with 1. So this becomes scores of 1 equals scores of 2. And since 0 is less than 5, you're going to do this line, and you're going to skip this one. 1 is less than 5, you're going to do this line and skip this one. And you can kind of go all the way down the line and process the whole thing. And then you can think about, well, if this is your original array, you can go through, and this is a trace. It's kind of doing the same idea with k kind of going down the side here, checking the condition k less than 5, whether that's true or false. And then scores of k equals scores of k plus 1 turns into this. So you're assigning 82 to score 0. That's how the 82 gets over there, right? This is taking 56 from here and assigning it to scores 1, right? And you're going to do this as long as this is true, because that requires you to do this statement. When it's false, you're going to do this statement, which basically says scores of k equals k minus 1, or scores of 5 equals 4, scores of 6 equals 5, and so on. So the rest of the array gets filled in with these values. So you end up with a solution that looks like this. In the beginning, it's sort of shifting the items over 1, and then in the end, it's just putting in numbers into those locations. It's kind of a tricky thing, but you have to be able to be comfortable picking apart a loop like this and figuring out, predicting what it's going to do in order to be able to write your own code to do similar types of operations. Does that make sense? You have to be able to read complicated code to be able to write complicated code. Otherwise, you're just taking a stab in the dark, right? So reading is good practice, and these kind of techniques can help you read code better. Questions? That is the end of the lecture. That's pretty good, right? So for the rest of the class, you can kind of work on these array problems. And let's, just to make sure I didn't screw anything up, let's just, before I leave, let's just download the lab. I don't want to leave Ben with a disaster in his hands, which could easily have been the case. I still have about 7 minutes, so we're going to download the starting file from this link. And we're going to open it. And we're going to put it in our favorite location. Oh, we had a question here. Let's see what's the... Is array problems all we have to do for the day? As in no more lecturing after you leave? That is correct. Just got to do those problems. Make it short and simple, but hopefully the problems will keep you engaged. And then open up the package.bluej. And open up array algorithms. There is a little bug here to get started, so we'll have to fix that right away. I want to make sure everybody has this up and running before I get going, so I'm going to walk around, and I want you to stop me if it doesn't. Have a problem getting it up and running? No, you can't still press that. Yeah, for Windows, yeah. Just log into one of those, or just rip the file. Just let it do it. Yeah, you can have an error, but I want to make sure you got it. Yeah, but it's things you don't have to remove the less index. Windows update is unusual. I don't like it. I will explain things. Yeah, but not right now. Wait while I get everybody going. I will take over your seat. You can take over the throne here, yeah. Okay, so most people have this up and running, and you can see what it looks like. You're actually, by the way, just for reference, you're not going to use arrays 4, 5, and 6 unless you do the bonus questions at the end. So those are only going to come into play for that. But in this case, problem 1 is doing the sum. So the reason why you get an error when you try to compile is because we haven't defined the sum method yet. So what we're going to do is we're going to go to the bottom of the file. And right between the last 2 curly braces, we're going to hit an enter and open up some space there for our first method. Now the first method is the sum method. So what should the remember what we call, remember the word, the signature or the prototype look like for this method? You don't know, do you? What should the signature, the first header, what should the header of the sum method look like? Sorry, say that again. Public static int sum, and then what? Int array, what? Int square brackets, what'd you call it, num set? Or maybe just nums? Okay, that is your first method, and just so it actually compiles, you can make it return 0. You're going to have to change this later, though, right? But it compiles, which is good, so I can leave knowing that everyone at least has code that compiles. Now, before I leave, I want you to do one more thing. Under the remove operation, no, it's the last one. It's the replace one. So invoke your method to replace the last item. No, this one here, number, what? Yeah. So let's add another one here to replace. So under number 8, I want you to add one thing to kind of give yourself a little extra challenge here. I want you to invoke your method to replace position, array 1 only has a few items, position 8 of array 1. And so in other words, you're going to put an 8 here, and it should, array should remain unchanged and no errors. So I just added something. Did you all see that? Well, look. Okay. Yeah. Okay. Questions before I head out of here? Leave it over to Ben. Mm-hmm. Yeah. Yeah, that's a good question for number 5. You can see how it's being invoked. You're just invoking the remove method on the array, and you're giving it the item that you want to remove, right? And when you're finished, you're just going to print out the value of array 1. You should see that one of those items is missing. Right. Will it give you an error if you try to redefine array 1 in the method? Well, according to my understanding, and Ben can correct me if I'm wrong, the variable of an array is a reference. It's a reference variable like an object reference variable. So if you change, well, that's why in that hint, it says you have to, when you're done, you have to assign the new array to the old array. Yeah, so like, this is where, before you finish that method, you better assign the copy to the original array. So that will, when you return from that method, it will actually be pointing to the new array that you created. You're actually throwing out the old array in the process. Yep, good questions. I'm glad you asked. Any other things before I head out of here? All righty. Ben, would you like to, should I just leave the recording running in case there's something you have to say, or would you like to? You're going to plug your laptop in? My laptop doesn't have a password. I shouldn't say this. So you could access all my personal files while I'm away. Yeah. And all of your grades are on here. Yeah. All right. I'll leave the recording running, so if somebody's watching this later, you'll just have to fast forward through. Question before I go? Yeah. Put it back on. Oh, the thing you're supposed to add. Yeah, you're supposed to add these 2 lines. So you want to invoke your method to replace position 8 with 15. And so basically you're just copying this statement and replacing the 2 with an 8. And that, if your code isn't working right, it's going to give you an error message. Okay. And those are the kind of things we worry about when we're working with data structures. This is good practice. Hope you all have fun. And I hope you don't finish it in 10 minutes and I'll leave. But I don't think that's going to happen. I would just stop there, and when you share yours, it will show up over here. So I'm going to stop the share for online folks, and this way, when Ben logs in and shares, you should be able to see his screen. The screen, and if you do want to stop sharing, just it's this red button right here. Okay. See that? Just click on that and it'll stop, and then you can share yours. Okay. Hopefully they're not.
Okay. You wanted to know a little bit more about references, or did you want to get that answered?
Before, I think I tried to, this is like erase out like set size and all that stuff, right? And then don't want somebody to ever come up with, the sizes that change from what it was originally in there.
It's not actually change the size of an array. Basically, like the idea of what happens is like the memory manager gives you a chunk of memory when you have it, right? And then it's basically, instead of giving you that array, it's just like, hey, this array starts here. And so
it's just a reference, and if you change the actual array, it's not going to.
If you
create a new array, if you have the new reference point to that one.
Yeah, exactly. That's exactly. So then if nothing is pointing to this array after a while, come along and be like,
Right.
That's actually every object. So, okay.
Oh, there's no autocomplete. It makes me so sad.
Why do we use the word static?
Like object, basically static is the way of attaching data to a class definition or variable definition. So, like a static variable, there is one variable for every instance. It's one way to think about it. There's, for a static variable, there's one like variable for every instance that's shared between every instance. So if you have like a static integer, and then you have like, you make one thing, then you make another thing, they're both pointing at that static variable, essentially. So that, yeah, as opposed to normal non-static variables, which each instance gets its own copy. I could demonstrate that if people want, but. So on the board, I can do it on the board. Wait, pens. Okay. So this may not be quite right because I'm not super up on my Java syntax. And I'll just pretend that I implemented all of the garbage that you have to implement for stuff. So if I say this, so if I have these two and I do something like this,
Two. A1 dot not share and A2 dot not share are different things. So each instance that I make gets its own memory essentially for a not shared member. But, and actually I think there's specific syntax for this. It should be something like A dot shared. 5. So this is like, it's like a member of the class itself. So all of A, all instances of A get this. And then scoping rules apply. So you could do something like in class A, you could do something like I really hate drawing brackets. Click. And so basically, even though the static variable is private, you can have every instance able to set shared state. You generally don't want to. Static variables tend to be kind of, no, they tend to be a little difficult to manage when you're dealing with objects that are things, like discrete concepts, and then you have this weird thing that shared between all of them. It can be very useful, but in general, you don't want to use them when you're designing. From your perspective, as sort of a class, a lot of stuff is going to be static because you're never, like, a lot of the things that you're saying, like the class that main is defined in, you're never going to instantiate those, and you're never going to call methods on that class. So you're basically just defining a whole bunch of free functions, with functions that aren't attached to nothing at all, but decided in its infinite wisdom that free functions are not allowed ever anywhere at all. So you, in order to make ones, you actually have to define class and the whole thing. But static methods work in much the same way. There's exactly one static method for every class, rather than every instance sort of having its own copy. It gets very complicated very quickly when you're talking about like the internals of what's happening. But you can think of it like that. Okay. I'm going to sit down. Is it? Yes.
Another thing about problem 5, I was wondering about when you're assigning the new thing.
Hold on, let me get an actual. All right. Okay, problem 5. Remove an element from an array. Okay, yes.
So like I figured out when it's copier, right? Like so I'm at the point where I have a copy array like already figured out, right?
Mm-hmm.
But it's supposed to be general, right? So if I just did, I called mine like ints or whatever, int array, ints, my original one. That's just the argument that's being passed, right? But it doesn't actually. Like, how would you change the reference to the original array? Like, could you do this, array 1?
No. So while the reference, like the object thing can be modified, but by default, the reference, essentially the address that gets passed into the function method can't be changed. Okay? So you should return another array from your function. Okay? You return a new array from your function.
But like in the problem 5 thing itself, I set up it just says remove then parentheses array 112, so it looks like a void method. It doesn't actually.
Yeah, and so you're trying to, I think that might have an artifact of the way that this assignment is set up is that there isn't a lot of information. There are ways to believe there are ways to get behavior that you're thinking about. The easiest way that I know about is just to return a new array rather than trying to do some weird stuff.
So you just like from nameness, you can say like array R1 equals remove whatever, and then I'll just return the thing.
Yeah.
Okay.
Ow.
Yeah, I know that's wrong. I just didn't remember how to fix it.
So something like that.
Oh, yeah.
Don't return null. I just did that. So that's how
Yes. No. I mean, unless you tell it to. So it like it's a function. It takes in a thing and it puts out a thing. Just leave that there for enterprising people to experiment with. I love
yes.
If you have bad it's just basically at this point you were able to gain some zero and it's going to say where you are. And so that actually it's the first part of your life. So basically, so you have R, right? And then outside of your function, you have and so your function says, okay, you come out here and you make a new array. And you point it forward. Okay, I want to write notice, array 2 is still working. You're returning this way. So what you have to do is once you're out of the code, you need to say array 2. As if
Can I use like an array pointer thing to not have to?
you can, but Java will hate you, don't do it. Because of the way Java is designed. Java is designed specifically to not use pointers. Yeah. Because pointers are terrible in a colloquial sense. Pointers give you way, way too much power in a lot of ways. I know. And if you like power, you should use C++. I know you can. I saw you in class. But in Java, they're like, this causes too many errors. We have people accessing memory all over the place. They don't mean to. You can just set a random pointer and say, access that memory over there, even if it doesn't even exist. Like, it's just. And then you get into things like, oh, different machines have different pointer weights. And so, yeah, and so Java's like, no, we're not letting you touch that unless you're really sure and we're also going to touch it. So that is why you can't use pointers. Good? Yeah. Satisfactory explanation. Okay. No. That's one of the reasons I prefer C# is because like the interop is a little bit like you can do it. It still doesn't like you to. And the other thing is like garbage collection is a thing. So because there aren't any manual pointers, you can have something going along, counting all of the references and making sure that nothing. Yeah. And actually, it causes a lot of problems if you do use pointers in one of these managed languages. I saw you. You have to manage the garbage collection very carefully, or else you start having memory leaks. Yes, hello.
So I'm not
Okay, this is what I was talking about. So I will repeat. Maybe I will do this. Are other people having trouble, like, with the assigning the array to your argument and not having it copy over the thing that's happening? Okay. So why don't you talk?
That makes sense.
Okay, that, yeah, probably a lot of people are going to be having that even though they're not there yet.
Okay. I'll do, if it happens one more time, I will stop. Okay. Basically, outside in your
However, I think I'm not sure my trouble.
so we call the function. You give it but then the function. So this doesn't exist anymore.
Like that's
Turn this. Array 2 is still pointing.
and then you say
So. If I see it again.
to make it a you see what I'm saying? Two straight words. You stick it up here, drop it forward, and then it
Did something say not to modify name?
No, I just assumed.
Okay. Okay. I just wanted to make sure there was like second.
In the method, you create subtract and you return that new. And then I just something simple.
Remember, the array isn't going.
Yeah.
You make an array and it's just that length forever.
So if I pull an around that gap.
Yeah, if you can't even pull a number out of the way, you can set it to a different thing.
Oh.
But it's like that space is never going to go, which is why you have to allocate new things. Copy stuff.
Well, the new thing would be taking the thing out and then copying, and then we copy.
Yeah. So you have your original, you make a new one that's one element less one. Oh, I should have found this.
Oh, wait, yeah, we already did that by doing this, right? Like the new array, the new array has, all these elements, all except for one piece on.
Yeah, and you just leave when you're copying, you just are like, oh, I should copy this one.
There's no
Well, and then put the thing inside, because I think it's not.
Yeah, and that's, yeah, you can do that.
But you already told me, you already told me that's.
Yeah, because you're doing a remove.
Oh, okay.
Yeah. By definition, that's one last.
You're actually going to be up one on this one right here. So cover this. You don't want to, you already have this. And now you can 0 fills.
So now I'm showing you.
Well, February 1 also.
Okay, so what you're doing, is you're going, so you're going around and it's saying,
So what
okay, does this one equal the element now? Contains equals false. It's true, not the other. And then it continues. Don't worry. Yeah.
Oh, this is. Oh, yeah, you know that.
Yeah, it is.
Well, I'm just saying, like, across here. You're probably more.
Yeah. Yeah, I'm almost done. Number 5? Yeah. What's up?
I'm returning the R10.
But I want R2 to then replace R1. Yeah, so you have to do that. And I have to do that. Yeah, it doesn't do that. At least the application. But I guess what I want is for it to be R1 equals R1. Yeah. Okay. Yeah. Yes.
Then I'm learning number 5.
Number 5 is really difficult. Yes. Okay, you are my third and final. Yeah, I think I might. The number 4 instead of the number that was 2. Yeah, so okay.
I got these 2 are the correct answers,
Okay.
but the actual like
I have now seen
copy over did not work.
I have now seen a problem occur enough times, and I'm going
Copy
to yell at the entire class about it.
yeah, you have to change it.
There are a couple things. First of all, not reading the right as you say, to modify a name, it appears that you will need to for the design. So you go in and you can assign things. The second thing I've seen is many people doing something like this. New array equals some stuff, and then in the argument array equals new array, and then return array. And they are wondering why array outside is not being modified. That seems to be what you're doing.
Yeah.
That's what you changed it to, but no, that's actually not the issue. And I'll show you later. So, can anybody tell me why this might be wrong? No, it's no, you can return an array. It's like built-in signature probably tells you. And this is in the remove method, by the way.
I think the idea is that the next array you're making is array minus 1. You're trying to make it smaller by so many, so it'll be minus 1 or minus 2, whatever the deal is. And then you specify what number needs to be removed. That being like an if statement or something, or not if statement, for statement. That has an if statement saying if this is equal to a certain number that must be removed.
So that's
then do so.
that is how you would copy, but that doesn't explain the Okay, now, okay. So when you're passing around objects, right? You're basically doing something like this. So outside, somewhere in main, there's something that looks like this. Array2 equals some array. I don't want to write it. And what this actually means is that array2 is a name that we're going to point at an object, which in this case is an array. When our remove function starts, we have some parameters. So remove array, integer. I spelled that out. Array, and then the value that we're going to get. That. And my handwriting is terrible. I already know this. This is why I type everything. So when we start this function, we pass in array2, right? And so basically this says, okay, I'm going to have a new variable. It's also going to point to this array. Inside remove, as mentioned by, I'm not sure what the name is, but we need to allocate a new array, which we will call descriptively new array. Please name your variables descriptively. It definitely helps. And so now we have new array. And we allocate some more memory. And new array is pointing to this object. What this statement, what this does here is say, this parameter that we've created, I would like this to point at this new array. And then we're going to return array, which is pointing at this. So your function ends, this gets returned. Great. Problem is, array 2 is still pointing at your original array, which is why your original array does not appear to be modified, because it's still there. So you will actually have to go into main and tell array 2 to point at this new object. And that is why that is not working.
Oh, that's why it's working. Okay.
Yes. Yes.
I thought I had it all down. It's not like right, it's a pointer pass.
Yeah. The pointer sometimes.
Number 8, we're saying to replace position 8. Yeah, array 1 only has the element, so position 8 will last.
That is correct. I'm not actually sure that this first one.
So are you saying we have to rewrite these method calls then?
Possibly.
Not possibly, I think we definitely have to.
Yeah, I think definitely have to.
So let's, yeah. No, I know what you're saying. So let me, I didn't have time to really process that. So let's see. So we have to say something like ARR1 equals remove of ARR1.
I don't see that.
So everyone, yeah, so you're going to need to define the methods kind of like that.
Yeah.
Question?
That's,
It shows up, right?
yeah, no. So the point of this exercise is actually to recreate this. Array does have like built-in methods for doing these things. And as I kind of here, there are actually even more methods. If you want to use like array.stream, and then you get like a whole bunch of stuff. But there is, as somebody who's been doing this for quite a long time and been through a couple interviewing processes, if you do not know how to like write a max function or a remove function like this, they're going to laugh you up. So
Yeah. Yeah, so doing these shortcuts isn't really going to help your
it's
career.
not really not going to help you. It's just too, and it's much more visible when you're actually in the job. I coded it.
But to answer your question specifically, what you wanted to do was, instead of doing this, you just want to invoke the method here followed by toString. But then you're not going to commit the changes to the array1, which the test plan is sort of showing you how it's going to evolve. So you'll be deviating from the test plan if you do it that way. So you should do it this way, where you, yeah.
There's the second but yeah, so don't worry about it. It's not too much. It's a new assignment. It has a little
What was, don't worry about what too much?
Just the access and the elements of the thing has elements in it, or has exactly 8 elements. So the
Does it have 8 by then? I thought it only had like 5.
no, I think
For number 8, right?
yeah, you like yeah. So the 8th element is the
Oh, are there actually that many items in there? Because 1, 2, 3, 4. There's only 5 in array 1.
yeah.
There's only 5 in array 1, and we removed them. So there should only be 5. So this should give you, this would give you an error if you don't check for a legal index. Yeah, the method should check to make sure that it's a valid index before it changes anything and throws an error, right? It just says array should remain unchanged and no errors. I did. Cover my bases. Yes. They're doing an automated for grading. I see. Well, I would like to get hold of those. I'm really tired of looking at code, man. That's okay. I did the grade. Actually, the labs aren't too bad. It's not really that big of a deal. How's the? Have you been able to test the homework 1? I think I'm gonna have to turn it in because it's due on the. I think it's due on the 18th or 21st. Okay. Half of it, what? That's a problem, Ben. Staying on task. I like to explore too while I'm doing these things. It is fun. Yeah, that's a good popular thing.
Okay.
Like I was sending three results. What are you getting?
So function
That was just right? It's a mess.
I probably stopped it. I think I stopped it. I remember it. Yeah. Hopefully I stopped it and it wasn't just not recording the whole time.
Some people like doing
Right.
It's not even removing the item. So.
Yeah. Yeah, let's go ahead and yeah, types of operations that they're going to be doing and the data structures later.
are like in place, and some a lot of them were like that can get in the way of conceptual models is to find out stuff. A lot of source functional stuff, a lot of things just by default treat everything as like
In place.
yeah, this is what you said it was. You can't ever change. You can add like to the end of it, but it'll always be that one thing. And so like lists and other functional things.
You mean you can't make it point to a new array? Yeah. Right.
Problem now. It's just a read. It's going to get better back into true. And then you add take all of these operations to the end of it and bring it by, but like doing stuff. It makes it like without knowing then once it for the first slide and it doesn't work, but then when the second slide comes again, it doesn't get that. I haven't done I tried to do all these then I realized I got it abstract out its economic operations. So like there's no like numeric interface. It has like an add method or a subtract method.
For objects.
Yeah.
No.
Like do a generic sum.
I see. I'm glad you found this productive. You did it all while you were helping people? You were just
Oh, no, I did that in like
wow. Okay, that's funny.
I got halfway through. Okay, so homework 1, I think it was working on lab 1, but I'm not sure. So I think I should be able to get to the end of like 1, but I don't know so maybe save the assignments that we get, and then we can like tweaking the code we get to output the correct, like in a format that'll run through the test will be pretty easy. That's something I can do in like 15, like a minute per assignment. And then we'll have test data that we can actually run things on.
That'd be great.
So I'm thinking maybe it won't be like like implemented this class, but you'll have like at least a couple assignments and labs.
That'd be great. This one would be real easy to automate, you know, the way it's written.
Oh, yeah.
So I think the way we revise things.
You wrote that whole like thing.
I wrote the Blue Jay program this morning and afternoon, and the lecture. They gave me a lecture, but it wasn't. Well, they didn't have any of the algorithm stuff. So they had the basics. So I kept all that stuff. But showing people how to do these things. And then what they had was it was what they called these replacements. They called them insert. When I looked at the test one, they were actually doing a replace, and I was worried about the complexity of doing an insert at any position, which they were.
Yeah.
Which was this? They called this, insert at a certain position, which is a lot harder, and it's more like the list. And I don't want to go that far into it. Yeah. Right. But when you, yeah. Anyway, good. Thank you.
Okay.
So maybe we should just still having to choose with the rate 3 and so no.
Maybe. I don't know exactly what. But basically, it's done because JE's count. Oh, and point